Let's see how we can calculate the equilibrium concentrations. Let's look at this reaction. The cis, the you'll see two stereoisomers of the stilbene. This is cis and that is trans. Those two are this the conformation reaction. The change of the conformation is in equilibrium. Cis stilbene is in equilibrium with trans stilbene, and the equilibrium constant was given as 24.0. Right, here is the reaction. So let's look at the stoichiometric relationship in the balanced chemical reaction. It is 1 to 1. Right. So next, what do is we set up a table called ICE. Initial value, change, and the equilibrium. The initial value, the initial concentrations in this table, this is the cis isomer and this is the trans isomer. Those are that is the concentration change table. The initial concentration for this example was given for cis-stilbene was given as 0.850, and there was no initial concentration or there was nothing from the trans-stilbene at the initial. Next, we don't know the equilibrium concentration. We assume an x amount of the reactant will be consumed. Then how much will be produced from the product? Yes, in order to find the amount that will be produced from the products will be determined based on the stoichiometric ratio from the balanced chemical reaction. Since it is the stoichiometric ratio is 1 to 1, therefore if X amount was consumed from the reactant, then again an X amount will be produced from the products. So minus X for the reactant and plus X for the that would be added to the products. So what is the equilibrium concentration for cis stilbene? Yes, it is initial minus X, that is 0.850 minus X, and the equilibrium concentration was assumed for the trans stilbene as just X. Okay, so then we write uh, the we write the the equilibrium constant expression, that is the trans stilbene divided by the cis stilbene. These are the equilibrium concentrations. So then we plug these values. The Kc was given as 24.0. The equilibrium trans stilbene concentration is X, and equilibrium concentration for cis stilbene is 0.850 minus X. So the X was calculated as 0.816 molar. So what is the cis stilbene? Yes, the X amount was determined, so we plug there. Yes, the equilibrium concentration for the cis stilbene is 0.034. The trans stilbene, the equilibrium trans stilbene was 0.18. So if you can again double check whether you have done the calculation correct, because you can use these equilibrium concentrations and find the equilibrium constant again, just to verify your calculation. Here is another reaction. Kc for the reaction of hydrogen and iodine to produce hydrogen iodide was given as there. The equilibrium constant was given as 54.3 and the reaction was balanced. And what will the concentrations be at equilibrium? If we start with 0.240 molar concentrations for both H2 and I2. Okay, the initial concentrations for the reactants are given. So what do we do? Yes, we set up the ice table. So this is the H2, this is I2, and this is the concentration of HI. These are the concentration. The initial concentration for the H2 is 0.24, I2 0.24, HI is 0. If I consider the change is X, okay, what is the stoichiometric balance, the stoichiometric ratio? 1 to 1 to 2, right? So if the X amount was consumed from H2, again an X amount will be consumed from I2 because it is 1 to 1. But 2X will be produced from the HI because here HI has the coefficient of 2 in its balance chemical reaction. So here is the equilibrium concentrations for H2 minus X, for I2 0.240 minus X, HI it is 2X. So then we plug these values for this equilibrium constant expression for this reaction, and we get a quadratic equation. We solve it and we obtain the X. Yes, here are the equilibrium concentrations for the H2, I2, and HI. Yes, we obtain those things from solving a quadratic equation. Oh, you will be afraid, right? Oh, is this algebra or calculus? No, don't worry. We do the calculations with an assumption. Let's move. Yes, we you don't need to worry about solving a quadratic equation. In this case, I'll tell you how to skip that part. When the equilibrium constant value is very small, then we can simplify that equilibrium problem. Look at this. I2 gas is in equilibrium with 2I gas. For this equilibrium constant was given as 3.39 times 10 to the negative 13. This is a very small equilibrium constant, right? The initial concentrations for the I2 gas was given as that 0.00155, and the Kc was given for this one as, oh, I'm sorry, here it says uh, it must be 12, 12, right? Okay, so we'll get the reaction and then we set up the ice table. This is I2, concentration of I2, and this is the concentration of I, right? Okay, so this is the initial concentration, and here is the is X, but 2X will be produced from the I because here there is a coefficient of 2. So we plug those values. These are the equilibrium concentrations derived using the X terms, and then I plug those values into this equation. Right. Since the equilibrium constant is very small, we assume this X is a negligible value. Is very, very, very small value. Therefore, 0.00155 minus X is approximately equals to the 0.00155. We say this is a negligible value. Now we simplify this equation to this. 3.39 times 10 to the negative 12 equals 2x squared and divided by 0.00155. Yes, now the problem was simplified. Now you can solve that, right? Yes, so now you can solve it up to here. uh, this part. Okay, so now you will get 1.31 times 10 to the negative 15 time equals to x squared. So then you just need to get the square root of this value, and x was equal to 3.62 times 10 to the negative 8. Yes, when the equilibrium constant is very small, we assume that x will be a very small value. Then if something minus x will be, if I said if this is m minus x will be approximately equals to the m. This is the assumption that we made here. Then you can mm, find the equilibrium concentrations of the other products like that. So if this is the uh, x was found, then we can find the concentration of equilibrium concentration of I2 as 0.00155 minus 3.62 times 10 to the negative 8. Okay, so then you can see that is very small value. So the 2x I equals to actually 2 times 3.62 times 10 to the negative 8. You will see this would be a very, very small value, and therefore our assumption will be correct. Here I have summarized the concepts, the principles that you should remember when you are doing a equilibrium concentration calculation. First, you need to construct that the I stable, initial, change, and the equilibrium. Then if the uh, first you can think, if you want to know whether it is in equilibrium or not, then you need to compare that with the Q value with the equilibrium constant. Mm. Next, for then from the balanced chemical equation, get the stoichiometry and fill the X appropriate or in relative to this stoichiometry ratio obtained from the balanced chemical reaction, and then solve for X. Using the X, find the equilibrium concentrations of the reactants and the products.